All right, Algebra 1A students. Welcome to part 2 of lesson 3-4 on solving multi-step inequalities. In this video, we are going to look at even more complicated inequalities and how we can solve them by combining like terms using the distributive property and even some special cases where the answer is not really a number or an inequality, but all of our variables disappear. We have to make a different decision. So we're going to start with probably the easiest example that we'll look at in this video, where we have parentheses in our original inequality with our variable piece inside there. And we need to use the distributive property to start simplifying this and get rid of the parentheses. So distributive property first here. So I would distribute this to there and there. And I would end up with, of course, 3t plus 3 minus 4t. And that's still greater than or equal to negative 5. Okay. Now the nice thing here is that I have two pieces that are essentially the same. 3t and minus 4t I can put together. I can combine those like terms because they both have a t and end up with negative 1t plus 3 is greater than or equal to negative 5. Right? And now I can solve for t. Now I can get t all by itself. First thing I do is subtract 3 from both sides. I end up with negative 1t is greater than or equal to negative 8. And then I just have to divide away the number attached to the t, which is a negative 1. Cross that out, negative 1. And t is, now I just divided by a negative 1, which means I have to flip my inequality sign around. That rule hasn't changed here. So it's now less than or equal to positive 8. Okay? T is less than or equal to positive 8 would be all the solutions to this. Which means in this original question, which of these four is a solution to this? Well, there's only one of these numbers that's less than or equal to 8, and that'd be this one. 8 is less than or equal to 8, so that would be my answer. But we should be okay using the distributive property, then combining like terms to get it to an inequality that we know how to solve very easily. Okay? Another type of multi-step inequality that we might see is when we have variables on both sides. Okay? The nice thing here is that there's no parentheses. There's nothing special that I have to do. All I have to do is move all my variables to one side, all my numbers to the other. And I'll try to always keep my variables to be positive, which means I'll take away the smaller number if I can. So in this case, I'm going to take away 3n to get those 3n to move over here, so that all of my n's, all of my variables are on one side. 6n take away 3 gives me 3n, says minus 1, greater than a positive 8. Nothing plus 8 is a positive 8. And now we should know how to solve this inequality. We have to undo the minus 1 by adding 1 on both sides. And I get 3n is greater than 9. And then to get n by itself, I have to divide by 3. And divide this by 3. And I get n is greater than 3. N is greater than 3. Now I didn't have to flip that sign because I divided by a positive number, not a negative. Okay? So hopefully you can see how we're using the same skills from chapter 2 of solving equations, moving variables to one side, numbers to the other, using distributive property and so on, to try to get the inequalities into something that we know how to solve very easily. The only other thing we have to deal with in this section is sometimes all of our variables disappear. Okay? Sometimes solving an inequality gives a statement that is always true, such as 4 is greater than 1. We know 4 is greater than 1, so this is always true. In that case, we would say the solutions are all real numbers. Okay? If the statement is never true, like saying 9 is less than or equal to negative 5, which is not true at all, we would say the equation has no solution. So when all of our variables disappear, we have to look at what is left over once all the variables are gone and decide if that's always true or never true. Okay, always will mean all real numbers, never means no solution. For example, we have this inequality here. 10 minus 8a is greater than or equal to 2 times 5 minus 4a. Well, the first thing I see I have to do is use the distributive property on the right-hand side. Distributing this will get rid of the parentheses and allow me to then move my variables to one side, my numbers to the other. Okay? 2 times 5 is 10. 2 times a negative 4 is a negative 8a. And the other side still says 10 minus 8a. Okay? Now I'm going to move all my variables to one side. So I'm going to take these negative 8a and move them to the other side by adding 8a. So those are now gone, and they get added over here. The problem is, when I do that, notice what happens on this side. Negative 8a plus 8a, well, that also cancels out, and I have 0 a's left, right? Those are all gone. They disappeared because I had negative 8 and I added 8 to it. Now there's none left. There's 0 a's. So what I am left with actually is 10 is greater than or equal to 10. So now all of my variables disappeared. They're all gone. And what I have to do is look at what's left and decide, is that always true or never true? Well, is 10 greater than or equal to 10? The answer is yes. 10 is greater than or equal to 10 because of this equal to line right here. So we say yes, which means the answer or the solutions to this inequality is all real numbers. Okay, that's my answer. This solution, what are the solutions of this? All real numbers. Any number will work. Any possible number you could put in will work here. All real numbers. Okay. The opposite would look like this. If I want to solve this inequality, 6m minus 5 is greater than 7m plus 7 minus m. The first thing that I notice is on the right-hand side over here, I have two terms that are like terms, so I can put these together. I can't add the 7 here to them because that doesn't have an m, but I can do 7m take away 1m. 7m take away 1m is 6m. So it says 6m plus 7. The other side says 6m minus 5. Okay? Now again, I want to get all of my variables to one side and all my numbers to the other. So I'm going to take away 6m on both sides so that those are gone. And I'm going to take away 6m over here. The issue again is that all my variables disappear, right? I had 6m on this side, and now I'm minusing 6m to get rid of these, but minusing 6m also gets rid of these. So those are also gone. What I'm left with is a negative 5 on that side and a 7 on this side. So my inequality now says negative 5 is greater than 7. Is negative 5 greater than 7? That's the question I have to ask. Is it greater than 7? No. No, it's not. So the solutions here, we would say no solutions. Okay? No solutions. Because what I'm left with once all my variables disappear is not true. Not true, no solutions. Okay? If you have questions, especially about this no solutions or all real numbers solutions, no solutions, all solutions, please make a note to ask me in class. Otherwise, that's all I have for you. Have a wonderful night.